Yes, no, yes, not very clear. Guys, I think it should be audible. Let me just test. Yes, no, yes, not very clear. Yeah, I think I'm audible, guys, because I can also test it in my system, right? Happy Ganesh Chaturthi, guys. Happy Ganesh Chaturthi. Okay, first of all, download the dataset from the link that is given in the description, guys. I've already put in the description all the links, so you'll be able to download it from there. Before that, a big announcement from where did I get the dataset. So his name is Akash Zade. I hope I'm pronouncing it right. He has actually given me the dataset, and he has also solved various projects in his blogs. You can actually go and see. He also has a YouTube channel in the name Indian AI Production. So he has given me the dataset, the same Google Drive link I have given in the description of this particular video. So a very cool work, Akash Zade. Thank you for sharing to the data science community. But with respect to the implementation, I'll show my way of implementation so that it will be handful. He has implemented in a different way by creating a CNN neural network for this, but I'll try to use transfer learning, which I've seen I was able to get a good accuracy. Apart from that, you'll also be seeing he also has an YouTube channel. Just go and follow this Indian AI Production. So where he has uploaded many videos as such, so here also you'll be able to refer that various different projects are there already. Okay, so just try to subscribe him and just try to follow him. And again, thank you, a big thank you for providing the data set. So I've given this Google Drive link in the description of this particular video. And the YouTube channel name is Indian AI Production. His LinkedIn ID also I've actually given in the description of this particular video. So if you really want to communicate to him, you can actually communicate and you can actually ask any type of questions. Okay, perfect. So let's go ahead and try to understand the further things. What are we doing in this? So I hope many people are asking that can we do image classification with many categories, how to do it, whether the accuracy will decrease, how things will happen and everything as such. Okay, and I hope first of all just download the dataset, guys. The link is given in the description. Google Drive link is there, and just download it and give me a thumbs up. Please everyone, just give me a thumbs up, then only we'll try to execute it. Okay, please just download the link and just let me know once you have done it. Please download the dataset, guys, and just let me know once. Okay, yes guys, please okay, till you download the dataset, I'll just be back in a minute. Okay, just download the dataset everyone quickly, please. Okay, so guys, I hope you have downloaded the images. Okay, and probably we will continue the discussion what we are going to do. So with respect to the images, guys, you can see over here we have 4 categories. One is diseased cotton leaf, diseased cotton plant, fresh cotton leaf, and fresh cotton plant, right? And nowadays there are a lot of research that are going with respect to agriculture things, where they are actually deploying drones. They are capturing the images and they are actually directly sending that feed, and trying to predict that what part of the drone is basically working fine or not. Okay, so because of that, what we can do is that we can also create some good algorithms. I mean, we can use some good transfer learnings. I have tried CNN. The accuracy was just, it was not going more than 80 to 85%, but definitely when I tried out with transfer learning, the accuracy was pretty much good. So that is the thing, like how you should decide which transfer learning will definitely work for this kind of classifications and all. That is what I'm going to discuss, and this is completely end to end. I've uploaded the GitHub link in the description. You can also download the code, but make sure, guys, if you don't have a GPU, and yes, one more thing, I really want to show how the training actually happens in my system, basically in my workstation with Titan RTX. If I have somewhere around 1500 to 2000 images, how fast it usually happens, and many more things. So let's go ahead. Can you give me a quick go ahead so that I start, guys? I'm just waiting for you to give me a quick go ahead. Just give me a thumbs up so that I will go ahead and try to implement this in front of you. Yeah, so shall we move ahead, guys? Yes. Yes, this video will also be available after the live session is done, guys. Okay, perfect. So first thing, let's go to Keras. Always remember, guys, whenever if you are implementing something with TensorFlow, probably Keras is the best thing that you can actually follow, right? So I'll just say Keras applications, right? So Keras applications, this is the most and beautiful thing that is provided by Keras, that is the transfer learning concept. Now usually what is the main thing with respect to transfer learning? When you have heard of GPT-3, right? It says that it is having 175 billion parameters. What does that basically mean? Internally, with respect to the nodes, with respect to the weights, with respect to different things, with respect to bias, there are a lot of parameters, that is actually present. And okay, Miss Starting Station, please give glance on this. Bhaskar Sai Kumar, we are trying to solve a problem wherein we are actually going to create a web app which will determine cotton disease predictions. Okay, so you just have to give the cotton image over there and it will tell you cotton leaves image, and it will tell you that it is basically having cotton disease or not. And some of the images I have already showed you. So these are some of the images. You can see that this is one diseased plant over here with respect to the leaves. You can see over here, right? So all these different kind of images are actually present. And again, I have also given the credits. Credits is given to Akash. His LinkedIn ID is given in the description. Thank you for providing these images so that I could implement in front of you. Probably in the next live session, I'll be taking like this 10 to 15 categories and try to show you different types of examples, right? So as I said that you can create CNN also from scratch. Probably with CNN scratch, I was able to get somewhere around 80 to 85% accuracy. When I try to use different layers. Apart from that, I try to use dropout layer, I use pre-relu activation function, and many more things. Okay, now over here, when I am actually seeing with respect to the transfer learning, guys, and probably you will be hearing something like parameters, right? When you take VGG16, it is having this many parameters, right? When you take VGG19, it is having different many parameters, with VGG16 and VGG19 also, it will give you a very good results. But when I tried using with ResNet 50 was this many parameters, and when I tried to use this, the accuracy was not that good. But when I started using something else, like if I tell you an example, I think I used this ResNet 15 to V2, which has 60 million parameters. Okay, which has 60 million parameters. When I tried to use this, the accuracy was amazing. Okay, the accuracy was amazing. So I'll try to execute this particular data set and try to see how good accuracy is there. And then we'll also be discussing about this web application, what I have actually developed based on the outputs. So as soon as you just give an image over here like this, Suppose I give an image from the validation dataset. See, this dataset is amazing, guys, because they have created train, test, and validation also. So if I go and take this as, and if I try to open it, if I do the prediction, probably it will give me an output of a specific category, unless and until it does not give me an error, or probably I just have to reload it. Let's see. So you can see this GPU memory is also okay. Okay, fine. Let this load. I think for the first time it will take more time, but I think it should work well. Let's see. Okay. But before that, all the code is given in the GitHub and you will be able to see it. Okay. So let me just see what is the problem. I think, did we get some error or what? Okay, this is not there. Oh, no. Okay, it is just loading for much time. Let me do one thing, guys. Let me just execute it in front of you so that you'll be able to see this. E drive, I have actually put that in my E drive. I'll just go in this working location and I'll do cd this python app.py. Okay, I'll just show you. Oh, okay, sorry, I did not go inside my environment. Activate my env. Okay, so I'll just clear the screen. Python app.py. So this has, you can see that it is using the GPU in my workstation that is present, right? Titan RTX. See over here, Titan RTX. Okay, fine. Let it come, and then probably I'll just reload this page and let's see how it works. Good to see you guys. Let's probably it'll taking some time. You can see now this memory will also start increasing to 20% once this is got executed correctly. Okay, till then this gets loaded. I am just going to show you first. I'll show you with respect to ResNet 50. Okay, and guys, if you really don't have GPU, try to execute this in Google Colab. Okay, because this is going to take time. This is going to definitely take time. Okay, so I hope why this is not executing. It's taking much time today. I don't know why. Oh, physical device, this environment plus app. It is correct. Okay, this is in the same working location. Okay, let it load. Till then, I'm just going to go over here and I'm going to basically show you how, with respect to Keras, how it will work, and I mean with respect to ResNet 50, what is the accuracy that I got. And here you'll also be able to see the speed of the execution. Okay, so guys, so first of all, this code that you see is just written for, you know, only for those people who has GPU in their local machine. Okay, and if you have GPU in the Google Colab also, you can write this. This basically says that you don't want to overclock your GPU. So I'm just saying that every time, you know, the GPU memory fraction that needs to be used is 0.5. Okay, that is 50%, not the whole. If it becomes whole, probably the TensorFlow library fails and it will not be able to give you the proper results. So because of that, I've executed this. So let me just execute this. I've just copied it from the TensorFlow documentation side because I was facing that particular problem where my GPU memory was getting full. Okay, my this detailed GPU memory usage, which I have 24 GB, it was getting full. Okay, it was trying to use the whole thing. Okay, so don't do that. Always try to give some GPU memory fraction. Okay, let's see whether this has got executed. Okay, it is not getting executed. Let's see. Okay, I've just reloaded it. Okay, let that happen. Now here I'm using TensorFlow version 2.2. Okay, so for that, whatever in Keras are there, you have to load like input, lambda, dense, flatten, ResNet 50. See, here is the main thing. I'm going to use the transfer learning technique as ResNet 50. So I'm going to import this ResNet 50. And if you don't know about ResNet 50, guys, just go and have a look. So this is what is ResNet 50 basically says. Everything is properly given in this Keras documentation. You can see that what type of input shape it usually takes and all the things. Okay. Now, one important thing that I have done is that I'm using transfer learning. Okay. So here also, you can see that I'm giving the image size as 224, 224. You can change the image size based on the data set that you actually have. Okay. Once you have different types of image size, you can actually give that. But with respect to this, you can also see that by default it uses 224, 224. So here I have specified image size as 224, 224. My training dataset path is given, my valid dataset path is given. Okay. So this valid path is nothing but the test path. Now, if you really want to download it, let me just execute this so that I will be able to execute it in front of you. Now, let me just change the description. ResNet 50, right? So I'm going to import the ResNet 50 library. Over here, I'm going to initialize. The input shape is basically given as image size, that is 224, 224. And since this is actually having an RGB image, so I'm going to use this 3 channels. Okay. So this whole channel, when I combine this, it will be 224, 224, 3. Okay. The second parameter is pretty much important with respect to the weights. The weight should be ImageNet if you really want to use the transfer learning, because ImageNet already have 1000 categories, right, with different images. Apart from that, it has huge number of images. So I'm going to use that pre-trained weights, and what I'm doing over here is that I'm including the top is equal to false. Top basically means the first layer, because the first layer I really want to say set my own image size. Okay. So what I do is that I remove the top layer, I remove the last layer. Last layer is removed because in our case, I have categories like only this 5 categories are there. Sorry, 4 categories are there. So I will be putting in my output node as 4. Now it is working, guys. Now you can see this. I'll just reload it. I'll choose an image, and this is diseased cotton plant. If I go and do the prediction, I hope this should work now. Successfully opened. Okay. Now here you can see that it is saying the leaf is diseased cotton plant. So we are able to get this output, and this is what I'll be explaining in the last, and this is just a demo for you all to understand how the output will actually come. If I use some other image, right, something like this, I'm going to use this fresh cotton leaf. Suppose this is my fresh cotton leaf, and if I try to do some prediction, it will say that the leaf is fresh cotton leaf. Okay. If I try to give some other images, let's see whether it will give us some error or not. Again, it is saying the leaf is fresh cotton leaf. Now here you can see this, guys. These are the validation images. I have not used these images for training. Okay. So here you can give any kind of images. Not only this. Let me try something else. Diseased cotton plant. This is diseased cotton plant, right? Let me see. I'll give this. Okay, it is saying fresh cotton plant. Okay, here I got one error. Let me give some other image. So it is saying diseased cotton plant, right? So all these things are there. It is working fine. So let's go back to this ResNet. Okay. So I have included the top as false. Okay. I'll execute this. And if you are executing for the first time, this will take some time to download the ResNet 50 that is present in that GitHub location, because that weights needs to be downloaded. Okay. The weight needs to be downloaded. Now this is a very important step where I'm saying that don't train all the layers. Why this is required? Because I am trying to use the same weights that is given in the ResNet 50 in the Keras blog. So that same weights I want to use. I don't want to train it, but instead I'll just train the last layer. So here you can see that the first layer and the last layer is not present. So what I'm going to do is that I'm not going to train the existing weight. So for this, I'm just putting for layer in ResNet.layers, layer.tryEnable is equal to false. I've just used this. Okay. Okay, guys. So about the BERT and the transformer sessions, I told you that it will be on Monday. Okay. Monday evening, 7:30. We'll start at 7:30. Then I'm getting the number of output classes with respect to that. This folders variable will be having the number of classes, and then I'm flattening it so that the reason why I'm flattening it, because I will be able to add the last number of layers, last number of nodes based on our wish, like based on our categories of the images. So for that I have to flatten this, and then you can see that finally I'm using a dense layer length of folders. This is my output node, like 3 nodes, 4 nodes, right? In our case it is 4, because if I just go and find the length of folders into this, see this, if I go and find the length of folders, right, I'm actually getting 4 over here, right? So I'm actually getting 4. So by this we will be able to see this, and then you will see that the activation function that I have applied softmax. If I have 2 categories, guys, I can use sigmoid. Okay, if I have 2 categories, but I have here many categories, and definitely I have to go ahead with softmax. Okay, because softmax helps you to find out the probability based on that n number of categories. Okay, and finally I'm converting that into a model where my resonate input is taken, and my output, whatever prediction I have actually created, it will be getting added. Now in short, this will be our model summary, guys. You can see that this many nodes. I'm just using this. This is actually having 50 layers, resonate 50 layers. It is a combination of convolution and all. And this flatten and the dense layer, you can see the number of nodes are 4. This is the main thing, right? This is the main thing. Don't worry about BERT and all. First of all, we'll cover the theoretical part on Monday, and then we will come to BERT and transformers. Don't worry. Okay. Finally, I'm compiling with categorical cross entropy, optimizer is Adam, and the metrics, that is accuracy. I think we have done this more as such. Here, this step, we have actually done the data augmentation for the training data set. Once we do this for training data set, our data augmentation, here data augmentation like zoom and horizontal flip will not happen for test. Only the scaling will happen. Okay, so this you have to remember it. Okay, guys, so I have executed this, and then I'm reading all the images. You can see there are 1951 images, 2000 images belonging to 4 classes, and then you can see that this is my test data set, 18 images belonging to 4 classes, right? And finally you will be able to see that I will be doing the fit. Now you can see, guys, I'm running this for 20 epochs. Okay, you can increase the number of epochs, and you can see that how the accuracy will be increasing and how the loss will be decreasing. Okay, anyhow, I have trained this particular model over here. You can see this model resonate 50.h5, but here you can see that how quickly the training is happening, and the reason is that obviously due to NVIDIA, and here you can see that the memory GPU usage is going till 50%, right? Whatever value we had actually given. So 20 epochs will quickly happen just in the span of less than 5 minutes. So here it is. You can see that this is getting used. The GPU is getting used. The GPU memory usage is getting used, right? How to handle multiple input size image? It's okay, guys. You can, Sachin, whenever you have multiple input size images, the data augmentation will be taking care of that semi-partially. Okay. You just do that only when you are not able to get a good accuracy. Okay, I'll tell you. Suppose if I don't get a good accuracy, at that time I'll definitely have a look onto that also. So by the end of the video, please guide how to use it with Google TPU, please. See, guys, I would like to suggest you try to use Google Colab GPU, because I think they provide Tesla over there, Tesla GPU, which actually helps you to do it. TPU. Probably I'll make a detailed video separately for that, why TPU is used and why other things are used. Now here you can see that, guys, initially my loss was 3.05, then my loss decreased to 1.034, 0.9701, 0.9417, and as the epochs are increasing, you can see that the value of the loss is also decreasing, right? Not only this, the validation loss has just decreased from 1.4 to 1.06. Then again it has increased. Okay, then we have got 0.8696 and 1.0169. We'll just try to have a look. Probably we'll be getting this kind of validation loss, and probably the validation loss is there because your images are less, 18 images in the test data set. So anyhow, let's see, because we still have to perform the test with respect to the validation data set, right? Okay, guys, are you able to understand? Can you give me a quick heads up if you are able to understand? The code is given in the description, because this will be amazing. Once I will be using this, I'll be showing you with respect to the end-to-end implementation by using this web application, this one, right? I'll also try to show you that. Okay, let's see. Okay, it has increased over here. The loss has increased over here, and the loss is again increasing here. Let's see what will happen at the end of the 20th epoch, because right now we are using resonate 50, guys. Okay, resonate 50, it has how many parameters? 25 million. Now what will happen after I train this? I will try to use this resonate, and it has 60 million parameters. There you will be able to see that how good the accuracy is. Okay, I'll try to show you because I have tried out with different transfer learning techniques. Okay. Kushal Singh says that can you run the same program Colab so that we can compare better the GPU speed? Definitely, but I think I have to upload that in my Google Drive and it will take time. Just try to do that and just pip install TensorFlow. That's it. Then automatically everything you'll be able to execute it. Or let me just make a video of same video where I will be executing it in the Google Colab. I have to put that whole file in my Google Drive. It will take time. Is 61 batch size, Krish? No, 61 is not batch size. Over here, if you go and see what is the batch size, is basically I think it is the validation not validation steps. Validation data, batch size. 61 is not the batch size in short, but the data set is basically getting divided into 61. Okay, just a second. I think I'm getting confused. Batch size is 32 over here. Okay, so 32. I'm taking in one batch 32 images. You can see over here. And if I have 1951 images, so 32 images like that, how many times it will be going and taking it? Batch size is 32. 61 you can say that 61 you can basically say that how many number of batches. Yeah, you can say that because from the total 1951 images, first time I am taking 31 images, how many number of times? So in short you can say it as a number of batches. Sometimes confusion happens, right? If you also want to see, let's see, 1951 divided by 32. Oh wait, I'll not execute it over here at least. 1951 divided by 32. I think I'll execute. So you can see that 60.9, right? So it is 61. Yeah. Number of batches. So after 17 epochs, you can see that the loss is decreasing again, guys. 0.60. We had started at 3.05. But the accuracy is somewhere around 72 to 74%, right? And the validation accuracy is 0.778. Okay. The validation accuracy is also good. It is not, I'm not saying that it is bad. It is good. You can see that both accuracy, this accuracy and validation accuracy are almost same, right? Almost same. Arvind Kumar sir, membership project. Arvind, you are not a member. Have you seen my today's membership project? I had already uploaded it, right? Just go and see in the live project playlist. So membership projects are going on, and I have also told members that from this coming week, Tuesday and Friday, I'll be uploading one video every week, Tuesday and Friday, where I'll be uploading membership videos for them. Okay. It will be available in the live project playlist. Okay. Now guys, you can see that 20 epochs, well, we did not get a good accuracy. It is ranging somewhere between 72 to 76. Okay. Maximum accuracy that I have seen is 76. Well, but with respect to the validation accuracy, again, I can see that it is somewhere around 0.778, 0.778. Okay. Now, one thing, let's see with respect to some different ResNet. Okay. Now, here, I also tried with Inception V3. You can see, guys, Inception V3 is having somewhere around 23 million parameters. And when I tried with Inception V3, right, let me just go and see where is Inception V3. With Inception V3, if I go and see my accuracy, the accuracy was somewhere around 94%. Okay, 94, 95, 96. You can also see that the validation accuracy that came was somewhere around 1.00. Okay. Now, I'll definitely not say that this is an overfitting condition. Okay, because both the validation and the training accuracy is almost same, right? So here you can just see, I don't know what has happened specifically, because if I talk about ResNet 50, the parameters are almost same. Inception V3 has parameters less than ResNet 50, right? But just with the change in the, I'll say with the change in the architecture, there's a huge difference. Okay, there is a huge difference with respect to this, right? Just with the change of the architecture. Not only that, guys. Then I went with this ResNet 152v2. Okay, 152v2. So if I go and open that one, you'll be able to see that the accuracy over here was pretty much amazing than the previous one. It was pretty much amazing than v3, right? I was able to get somewhere around 98% accuracy with respect to the training data set. And right now you can see that just by comparing things, you can actually do a lot of things by comparing this. Just try to see that, okay, this is having some bigger parameters probably. And also one more thing, guys, sometimes if you tell me, okay, Krish, what would you select between ResNet 152v2, which is having somewhere around 60 million parameters, or will you select Inception v3? Will you select this? What do you say, guys? Which one should I select? Whether I should go with Inception v3 or whether I should go with ResNet 152v2? ResNet 152v2 is basically having 60 million parameters, whereas Inception v3 is having 23 million parameters. Which one should I go ahead with? Just tell me whether I should go with Inception v3 or whether I should go with ResNet 152v2. Okay, many people are I just got two answers. Come on, guys, let's go with Inception v3, right? But why you are suggesting Inception v3? Just think over it and tell me. Why are you going ahead with Inception v3? Why? Tell me the reason. Why? Why Inception v3? Why not ResNet 152v2? Less number of parameters. What will happen? What will happen if there are less number of parameters? Tell me. Less time for execution. Perfect, guys. So whenever you have this kind of condition, and you can see that the accuracy it differs very, very less, right? Here you are able to get 98%. Here you are able to get somewhere around 96%, right? Even though your validation accuracy is coming as 1. We should try to take this, according to me. If I was a developer and if I tested between these two layers, these two models, I would definitely go with Inception v3 because I'm able to get some good accuracy, and I also want less response time, right? Less response time. Probably so why I was executing this was taking more time to provide you the response. Why? The reason is that I have actually used over here. You can see that I have used ResNet 152v2, right? Now let's try this with this model, that is Inception 1. So I have also created this Inception model. So let's see, where is that? Okay, in model_inception.h5. Let's see whether I make this change, something will happen or not. So I'm just going to do this Inception. Now see this. This is an amazing thing, guys. My app is still running over here, right? See, it has started re-executing things. See, it has started re-executing things. I'll save it. Now it'll just reload it automatically, right? I'm making that change. It is reloading automatically. So let's see how the accuracy will come over here. So I have this 127.0.0.1. Probably for the first time, I think it may take some time, but I think it should be less than the previous one. Okay, so let me see some diseased cotton leaf. Okay. So you can see over here, this is getting executed. Oh, perfect. See this, how fast it got loaded, right? Yes, are those model trains? Yes, guys, I have trained all this particular model. I cannot just give you this model file because it will take time. Probably I can upload it in the Google Drive, but you just try to execute this, okay? Just try to execute it, at least keep 10 to 15 epochs, so you will be able to do this. But just understand, this accuracy we have got in just 20 epochs. If I increase it to 50, probably we'll be able to do a whole lot of things. Jainam Sharma, how can we use Intel GPU? Intel GPU is, you cannot, guys, because CUDA libraries is actually given to NVIDIA GPUs, right? It is compatible to them. Yeah. So yeah, this preloading and all I'll be doing, guys. But remember, if the model size becomes huge, if there are many parameters, that many calculations will happen. And right now I'm executing this in my GPU, right? So probably that calculation will happen quickly, right? It'll definitely happen quickly. But when it happens quickly, okay, when it happens quickly, the one more thing that you need to focus on is that suppose if you execute it in your local system, at that time what will happen, right? At that time what will happen in that particular case, right? So this is pretty much important and critical, that you need to understand how to select, how to ingeniously select your model so that your response time should be less, and your response time should be very, very less. I know in server we try to select some very, very good things, right? So let's try with other things, right? So suppose if, let me just try one more and let me predict it. Now see how fast it is becoming, right? Now it is preloaded, it is doing the calculation quickly. Fresh cotton plant, right? It is happening very, very quickly. Predict it. Yeah. So is GPU required for inference? No, not necessary. Okay, because this will be a pre-compiled model only, right? But it do helps. Apart from that, I have a good processor, so because of that I'm able to get all these things. So did you like this tutorial, everyone? Yeah. Okay, in the upcoming videos I'll also show you how you can convert TensorFlow into TensorFlow JS, and many more things are going to come up. I'm also planning for reinforcement learning techniques, probably, and the materials have been created. We'll try to teach that also. Monday evening you'll be having BERT and transformers. Okay, you want this trained H5 files. Let me see what is the size of this. If the size is too much, and sometimes it becomes difficult. See, this is somewhere around 94,000 KB, 88,000 KB, 2,84,000 KB. Now just see the size difference, guys, between Inception and Resonate 152V2, right? Go with Google Colab, guys. Let me just see whether I can do it in Google Colab or not. Okay. Google Colab is pretty much simple. Just go with Google Colab, try to execute this. Okay. Google Colab is pretty much simple. Just create a new notebook. Okay, like this. Just create a new notebook. Okay. Once it is created, just go over here, right? Just go over here, connect it to runtime to enable the browsing. I think it is somewhere here. Wait, I think we need to write a code or just see this video, guys. I think I have created a video on this also. Okay, I will be giving the link of this, how to read dataset in Google Colab from Google Drive. Okay, training ANN using Google Colab GPU. So just try to see these two videos. I think you will be able to understand it. Okay. Change run type. Run type is basically GPU. Insert. I think this has got changed or what? Where is that connection? I think we need to write a code to connect. Okay, here it is. Oh, here also you can upload it, I guess. Let's see whether I can upload this dataset. Okay, you can upload it like this also. Otherwise, you can also connect to Mount Drive. Mounting Drive, connect to Google Drive. Okay, so just select your Google Drive over here. Okay, probably if it works fine, you just have to connect it, and then you can actually write that code from google.colab import drive.mount content. Yes, so here you can see this drive. This is my drive. Okay, so all the files are actually present over here. So inside this drive, you just go and upload this thing, right? Upload this data set, and then you can actually write down the code over here. Just go and see this videos, guys. You'll be able to understand it. Okay, so how to read data sets in Google Colab from Google Drive, training artificial neural network using Google Colab GPU. Okay, so just try it out. Then if you really want one, I'll just create a video. That is also fine, I guess. And remaining all is given over here. Just execute it, create that H5 file, then save it in the Google Drive itself, right? Again, saving is the same functionality like how I've saved over here. You can see over here, I have just saved this model.save, this one, right? You just have to write model.save. How much time to train the model? For me, hardly it took 5 minutes. In Google GPU, within 10-15 minutes, it will get trained. Okay, it is having only 2000 images. I think it should work fine. So do deployment. This same deployment. See, this file is already with the proc file, right? Proc file is there. This deployment will not happen in probably it should happen. So what is the file size? Let's see. 88 KB. So guys, 88,000 KB. So probably it will be more than 88 MB. In Heroku, you won't be able to do this, but in other platforms like Google Cloud or AWS EC2 instance, you can actually do that. Okay. Mohammed Jafar says, so check out your email about mobile net demo using Streamlit. I'll have a look. Okay, what is that application that you created? Could you do the reinforcement playlist? Sure, I will be doing it. Kaushik, I'm planning for that. The materials are ready. You can see over here. See, the reinforcement learning materials are ready. So I will be teaching. I'll be start teaching this soon. You know, I've just created this. iNeuron has also helped me to get this particular materials. It is provided them. They created it. Let's see. I will start doing this once I am ready, right? So that will also be taken in the live session. Mohammed Jafar, Heroku app, it will not be okay. Heroku app is fine, but tell me what type of classification you have done. Image classification. What images classification you have done? While evaluating accuracy, it takes a lot of time, 45 minutes for one epoch. Please suggest we tried in Google Colab only. 11,000 images, for me also I think it will take time, but it may happen. One epoch is very much, 45 minutes it will not take in my workstation. But 11,000 images are a huge number of images, guys, right? 11,000 are a huge number of images. So probably I think you have to do it in Google Colab, or just try to take one virtual paper space, paperspace.com. Just go and take it. I think within 1 hour you'll be able to do that. Over there you'll be able to get P4000, P5000 GPUs. Okay. Friday Transformer birth session was happened. No, Ganeshwar Rao, it will be on Monday. I've announced that, right? So hit the like button, guys, if you like this video. I hope you were able to understand a lot of things. So do we really need external GPU to make the epoch run faster? No, you need some better GPU with good amount of memory. This is very much important. Now I have 24 GB. Suppose if I have 48 GB, the execution will be more faster, because I'll be able to take the batch size images pretty much bigger, right? You need to have good amount of memory. Suppose if you have Titan RTX, and suppose if you have 48 GB, right? Right now what the execution is happening, it will become much more better. Like suppose I think in this, how to see the NVIDIA. Let's see what GPU this Colab provides. Okay, so if I go and execute this, you'll be able to see that this is having CUDA CUDA version 10.1. I don't see the GPU. How to see the GPU name? I've changed the runtime, right? I think 11 GB, that is what I had heard. Check GPU in Google Colab. I think this will work. To enable GPU testing for GPU, you can usually use this one. Okay, fine. Let's see. So I will be importing import TensorFlow as TF, and I'll just use this. Let's see how much time it will take. Or device name, I think instead of device name I will be using, I think it will have something like Tesla K80. Test GPU device name, GPU available, GPU name, check GPU name in Google Colab. Listing devices, checking RAM. I think, but we could see the RAM, right? Initially. NVIDIA Tesla K80 GPU 12 GB. Can you tell me what is the command that you have used? Ganesh, what is the command that you have used? Top corner side. Which top corner? Okay, Google it which GPU is used in Google Colab. That also is there. But I think I can use some commands. Which GPU is used in Google Colab? I think we can see that. Okay, NVIDIA Tesla. Okay, NVIDIA Tesla K80. As of 13, this is provides us 12 GB NVIDIA Tesla K80. What is the cost of NVIDIA Tesla K80 versus Titan RTX? Let's see. Like Titan RTX. So here are some websites. Or just let me just search what is the cost. Oh, so I think Titan RTX is better than this one, Tesla K80. Titan RTX is $2,500. So, okay, placing in performance 9th. Performance rating is 9. Architecture, Turing, this is the price. Okay, so I think it will perform better. Pipelines 4608. So this is the cores. The cores is very, very less. Boost clock, transistor count. So I think it will. This is basically double the speed, right? ANN regression की model accuracy कैसे पता करे क्रिश भाई? There are a lot of things like R square, adjusted R square, mean absolute error, mean squared error, and many more things. Yes, this video will be available after live. Yeah. So guys, did you like this video? Can I get a quick go ahead like this? Thumbs up डालो यार. पता नहीं रोज लाइव लेता हूँ 200 लोग ही रहते हैं, पता नहीं क्या है प्रॉब्लम. लोगों को फ्री कंटेंट पसंद नहीं है क्या? People don't like free content, I guess. Yeah. Video ಚೆನ್ನಾಗಿತ್ತು ಕ್ರಿಶ್. Okay, in Kannada. Right? I don't understand. Only 210 people will be watching, and I think 7 dislikes will be there. One person will be coming for dislike only, and that I definitely know. But all this free content, people are not joining in lives. Then what is the use of taking live? That is the thing, right? How to get into Google as data scientist? Just do some amazing work, showcase to the world, make people learn like anything. Can you please teach ResNet? Architecture is simple, guys. Understand CNN. Remaining all are architecture changes. They are moving here and there, and they are basically doing it. Okay. भाई लोगों को इतना नॉलेज नहीं है. बाय द वे इट्स वेरी यूजफुल. इट्स ए लॉस फॉर दोज हु आर नॉट ज्वाइनिंग. शेयर मटेरियल ऑफ री इन्फोर्समेंट. भाई अभी चालू भी नहीं किया, पहले ही शेयर कर दूं. थोड़ा भी सब्र नहीं है लोगों को. Okay, perfect. Okay, guys, this was from my side. For the members, the next project that I am planning to do is, let's see, for the members, this is specifically for the members. Tomato disease. I think tomato disease Kaggle. Okay, so I am actually going to do this. This is an amazing and complicated project because I have just seen the data set. The data set is amazing. It has 11 categories. That is the major problem. If I go and see the training and the test data set, you can see over here, guys, so many categories are there. So probably I will be doing this next project. The reason why I'm taking this project, because I really want to understand image classification when it will go bad. If you have many number of categories, or when you will be having many other problems. So I will be taking this and I'll be solving this particular problem statement. I think this was a competition and this was uploaded by someone. So thanks to this guy, he has created this data set and made our work easy. Just understand, guys, how many images are there in one folder. In this it is 1672. So now even for training this, for me it will take somewhere around, I don't know, 1 hour, because if I go and see this, more than 30,000 images are there. Okay. Dada Kalandar says, sir, you are simply awesome. I believe most of the institutes are watching your videos to teach their students. Thank you. Thank you. And what is the summary? Okay. Okay, the validation data set and this data set is there. I will use this and I've downloaded it anyway for the next session. Let's see. And tomorrow live session, I'm going to discuss about rapid AI NVIDIA. Okay, so I'm going to discuss about this amazing open source library. With this Rapids AI, you can also execute machine learning in GPUs. Just imagine. Isn't it amazing? So tomorrow probably I'll be discussing about that, GPU accelerated data analytics and machine learning. So if you really want to do machine learning, you can use this Rapids and probably do the work pretty much faster. Let's go and explore this. Tomorrow I'm going to put 1 hour. Let's see any new things comes, we should try to explore. Okay, so these are some of the examples. 100 times faster machine learning models ensembler with Rapids, QML and scikit-learn metas estimator. Hyperparameter optimization on Microsoft Azure using Rapids and NVIDIA GPUs. NLP and text processing with Rapids. Now simpler and faster. So we'll try to see this, how to work with this and all. Again, I'm also pretty much new. I'll just open this page, go to the Jupyter notebook. The example notebooks are given over here. Try to execute and try to learn along with you, right? And then you'll also be getting an idea like how do I learn, right? So here you can see that this is amazing, right? This is some type of operations. You can see that this operation, this kind of operation, we can actually do it in, the GPU, which will be pretty much amazing. Tell me the tomorrow's timing, guys. I will try to come. Do you want me to come at 6 o'clock or the same time is fine? Yeah. 66677. Kisle 3 p.m. is not possible, man. No, this Rapid AI is for everyone. The next project that I'll be uploading for members is this tomatoes one. Okay, plant disease data augmented like this. Same time, 7 to 8. No, tomorrow the class will be for everyone, guys. Okay. Okay, fine. Let's do it at 7 p.m. I think we have something else, but it's okay. Let's do it at 7 p.m. Okay. Okay, let's do it at 7 p.m. Okay, fine. So, happy Ganesh Chaturthi, everyone. Enjoy your remaining day. Keep on learning, keep on enjoying your life, and don't worry about the future or the present or the past. At the end of the day, the story never ends. It will be going on. Some good things will be happening, some bad things will be happening. You have to keep on going on. You have to always say that tomorrow is a bright day again. Just keep on working on it. And please do subscribe the channel if you have not already subscribed. And if you have any other things, you can let me know. You can communicate. You can write the the comments of this particular video. And yes, thank you. I'll see you all in the tomorrow's video. Bye bye. Have a great day, guys. I'll see you all. Bye bye, everyone. Have a great day. Amazing, right? And keep everyone happy. Stop hating things. Keep loving everyone. Keep on working with everyone. Keep on teaching everyone. Try to share knowledge with everyone. Remove the hateness in the society and along in your heart, right? Always be good. Always be fun. Always be loving. And yes, this was all from my side. I'll see you tomorrow. Bye.